physics students. Today we'll be discussing work and energy, a fairly common topic in AP Physics 1. So let's begin by talking about work. What is work? I want you to think about that for a second. Work isn't just, oh, I'm doing work. Well, that's how we talk about it, but what is it in physics? Work is done when a force is applied to an object, and that force causes the object to move. So if there's no motion, there's no work. The formula for work is work equals F times D cosine theta. Now, F represents the force, which is in newtons. D is referring to the displacement. And theta is not just any other angle. It's the between the force, angle between the force and the direction of motion. Okay, so it's not just some like random angle. It's between the force and the direction of motion. Now let's do a quick example. Imagine if you're lifting let's say there's a box right here. Let's say it's 10 kilograms. Let's say you're lifting it 2 meters off the ground. What is the force that is needed to lift it that many meters? Well, force to find the force is equal to mass times gravity, which is equal to 98 newtons. Because we're assuming that we're lifting it as a constant speed, so the force of gravity is the only force that's acting on it. So the force is 98 newtons. Now, according to our formula, W is equal to force times theta, D times cosine theta. So the work done is equal to the 98 times the displacement, which is 2, times cosine of theta. Now, what is theta? Well, the direction of motion is upwards, and given that theta is between the force and the direction of motion. So what angle is between, if this is the force and this is the direction of motion, what is the force between these two? What is the angle? The angle is 0 degrees, right? So what is cosine of 0? Cosine of 0 is just 1. So that means that the work done is equal to 196. 96 what? 196 what? Because it's you can think of it as Newton meters, or in this case, it's commonly used as joules, which is a unit of energy. Now that we know about work, let's talk about energy. Energy is the ability to do work, okay? That's a really important concept to understand. Energy is the ability to do work, okay? It's not some like, oh, I have so low energy. Oh my god. No. It's the ability to work. I guess you could think of it in that sense, but not really. But yeah. So kinetic energy. Let's talk about kinetic energy, or KE. The formula for kinetic energy is kinetic energy equals 1/2 mv squared. Now, this m represents the mass, and v represents the speed, not velocity, because you don't really need velocity. You're not saying, oh, exhibiting 34 joules of kinetic energy to the right. You don't say that. So it's usually representing the speed / velocity. But I guess you could think of it as the velocity as well. Now let's do a quick example. So let's say you have a car that has a mass of 1,000 kilograms and is moving at 20 meters per second. What is the kinetic energy? Well, the kinetic energy is equal to 1/2 times the mass. The mass is 1,000. 1,000 m. 1/2 m v squared. V is 20, so 20 squared. Now we know that this is equal to 1,000 divided by 2 is 500 times 20 squared, which is 400. So this is equal to sorry about that. If you plug it into your calculator, if you just want to be sure to do so, you would get 200,000 joules. That's a lot of joules. Not gonna lie. So you can clearly see that there's a lot of energy. Energy is not just a 1 joule. 1 joule is like barely anything. Okay. So yeah. Now let's talk about another type of energy: potential energy. This is one of my favorite ones. Potential energy. We're talking about the gravitational potential energy, or the GPE in this case. And this is the energy that's stored in an object because of its position, usually relative to Earth. The formula is PE equals mgh. M is the mass, G is the just the gravitational value, which is 9.8 meters per second squared, and H is the height. And usually the height is the H naught or H zero is usually assumed to be zero since you're using it relative to the ground. Now let's do an example. So imagine you have a rock. Just imagine that's a rock. Let's say it's 5 kilograms, and let's say it's 5 meters above the ground. What is the potential energy of that rock? Well, potential energy is equal to m, so it'd be 5 times g, which is 9.8, times the height, which is also 5. So this equals, if you plug it into your calculator, this equals 245 joules. That's how much gravitational potential energy is. Now, another key concept to cover is the work energy theorem. The work energy theorem. Now, the work energy theorem is a really important concept. So, it essentially says that work is equal to the change in kinetic energy. And this is equal to the kinetic energy final minus the kinetic energy initial. And kinetic energy, we already know, is 1/2 mv squared. Now, the final, which is represented by v squared, and then the initial, we just do the exact same thing, 1/2 m, but instead of v, we put v naught, since it's referring to the initial. So that's what the work is equal to in this case as well. This means that if you apply a force to an object and it moves, you're doing work, and the work results in a change in the object's kinetic energy. Let's see this in action with a quick example. All right. So let's say we have a car of mass 1500. Let's say it's 1500 kilograms. Okay. This car, weird car, but it's fine. It's moving at a speed of 10 meters per second, and it speeds up to 20 meters per second. Now we're told how much work was done by the engine. All right, so first let's find some variables. So kinetic energy initial is equal to 1/2 times the mass, which is 1500 times v squared, which is 10. 10 is the initial speed, so 10 squared. And this is equal to, if you plug it into our calculator, we get 75,000 joules. Now, if you're trying to calculate the change, we need the final as well. So kinetic energy final is equal to also 1/2 m, which is 1500, v squared. So v is 20 since we're increasing the speed, so 20 squared. And this is equal to 300,000 joules. Now, the work done is just the change in kinetic energy. So the work is equal to the 300,000. I'm just going to abbreviate, put 300K minus 75K, which is equal to 225,000 joules. So the engine did about 225,000 joules of work to speed up the car. Now let's talk about another important type of energy. It's known as mechanical energy. Mechanical energy is essentially which says that in a system with no external forces like friction, the total mechanical energy is essentially equal to the total potential energy plus the total kinetic energy. And this is just a concept you need to know going forward in your physics classes because this will be covered very extensively as well. Now let's briefly talk about power. Power is not just like Superman, how much power you have. Power is the rate at which work is done or energy is transferred. It's measured in watts, where one watt is equal to 1 joule per second. 1 joule per second. So if you say, oh, my 20-watt phone charger, that's actually 20 joules per second. That's the amount of energy that's transferred. Now, for example, let's say you have a light bulb. So you have a light bulb. Let's say it's doing a work of, let's say it's 10 joules, for example, hypothetically speaking, and 5 seconds. What is the power? Well, the power is just the work over the time, work over time. So it's just 10 over 5, which is equal to 2 watts. That's a pretty weak light bulb, I'm not going to lie, but that's how much it is. To wrap up, work and energy are the essential concepts in physics that explain how forces cause motion and how energy is transferred or transformed. From lifting objects to speeding up cars to roller coasters flying down hills, work and energy are everywhere, okay? You lifting up your phone, that's work. You eating, that is work. Everything is work, okay? If you find this video helpful, don't forget to like, comment, and subscribe for more physics and calculus and anything pretty much. And yeah, keep practicing. Lock in, okay? Physics midterms are going to be coming up soon, so you need to lock in, okay? All right.